Hello students, once again you're welcome to Waidsum University. This is Networking Essential Management, and this is chapter 5 section 3. Okay, and the topic for today is the network switch. Now without much ado, let's begin. Okay, first of all, what is a network switch, or what is it used for? Okay, a network switch, what is it used for? Okay, we have a network switch used in different layer of the OSM model. We have it used in different layer. We have it can be used in layer 2. Okay, it can be used in layer 3. Layer 2 is used or controlled with the MAC address, using the MAC address, the switch LAN. It's data packet addresses or header from the data packet through the MAC address that is designated on the data packet. Okay, for layer 3, which is the network model, then this one operates as if it's a router. Then we also have layer 4 switches that uses the protocol to learn the new technology. So, but let's first of all talk about switches be using layer 2. Let's talk about switches be using layer 2. Okay, let's take a pen and take a highlighter to help us. Now we say the layer 2 switch is an improved technology, right? It's an improved technology that addresses the issue of providing direct data connections every time we use it to connect our network, to connect our hosts, our computers. Okay, to connect them and make them communicate, so that the whole essence of switch is to enable computers to communicate. Okay, I send something, the switch takes it, process it, and send it to the destination where I'm sending it to. So that's the whole essence. Okay, to connect LAN, local area network, and enable computers and printers to communicate with one another. So we say layer 2 switch, one of the big advantages that it improves or provides what we call the direct data connections. Okay, direct data connections between one host and another host. That's the first big advantage from what we call the switch layer or layer 2 switches. The next big advantage for switches is to minimize data collision. This is very important because data collisions happen a lot with other connected devices or network devices like the bridge and the hubs. So the switch minimizes a lot of data collisions. Then another advantage or super advantage from using switch in layer 2 level is maximizes the use of LAN bandwidth. So whenever, because when a switch, a computer in a switch is sending a message to another computer in a port, learns a port. So the two port connects, port 1 maybe and port 6, they connect with each other, and once they are communicated, they bound other this thing from messages from other computer to interfere with this. So as such, it maximizes the bandwidth at point in time, because it establishes connections between two ports, and those two ports communicates, and as they do that, the bandwidth of the channel is maximized for them to use. So we've itemized some of these advantages for layer 2 switches. One is it provides a direct data connections and it minimizes data collision rate, and then the third one is that it maximizes the bandwidth of the local area network. Okay, so that's to say, with regards to maximization of the bandwidth, it means that it will improve the efficiency of the data transfer rate in the network, because if your bandwidth is maximized or is effectively used, then there will be high efficiency in your data transfer rate in your network. Okay, so that's that for that. Now we say the switch that operates in layer 2 of the OSM model, they use what we call the MAC address. They use the MAC address. You know, remember the MAC address is also called the Ethernet address. They use the MAC address for any decision they will be making, or any decision they make regarding forwarding any data packet, regarding two hosts forwarding data packet to each other, or a host, a computer, forwarding a data packet to a printer or the network. It could be a laser printer, a colored printer, a inkjet printer on the network. That is a step that once an establishment has been made between a connection, an association has been made between two data packets or between two hosts or two ports on this can only be enhanced with the use of a MAC address. The MAC address of the two hosts are being established by the switch, and a link is created for them using the two ports in order for data to be transferred between these two ports, or between these two hosts on the network. Now the switch monitors data transfer on its port. Every time there's a data transfer on the port, the switch will monitor the particular data transfer on those ports. All the data transfer will need those ports, and it will collect the MAC address information in those ports the same way the bridge does, the way we've talked about the bridge. So the switch will collect the MAC address of the collect all the MAC addresses of the informations in those ports, right? And then have what we call a table, a switch table, and then we record this on their own switch table. Is that okay? Just like the way build up a MAC addresses for the device connected in the port, just like the way the bridge does. Okay, in this regard. Now the switch has multi ports, or like the bridge just have maybe 1 and 2, like 2 ports. Okay, and then the bridge uses those 2 ports to create network segment, LAN A, LAN B, you know. But this segmentation of network, it's also cumbersome, because you don't see what is happening. If you are in LAN A, local area network A, you don't understand what is going on in the local area network B. So it's kind of create a segment like you are isolated, you know, a particular segment is so it's also a negative somehow for network. But a switch doesn't have to do it has multiple ports similar to that of a hub, but it has its own advantage over a hub. We're going to talk about that, right? So the switch has a lot of ports, multiple ports, up to 24 ports, okay, that you can simultaneously use. And you can connect, you know, from one switch you connect a hub to one switch, and you can have multiple computer in that hub, then that is connected to a port, a single port on a switch. So you can have a huge computer be connected together using a switch and maybe a hub together. Okay, so a switch has multiple ports similar to the hub, and can switch in a data connection from any port to any other port in the same manner that the bridge uses. It can switch data connection from one port to another port in the same manner the bridge uses. Now this is why the switch is sometimes called multi-port bridge. So sometimes we call the switch a multi-port bridge, because although bridge just have 2 ports that communicate with each other, but a switch has multi ports, a lot of them, but 2 of them will establish their connection one at a time. We're going to establish this, okay? We're going to show it diagrammatically. The switch minimizes the traffic congestion and isolate data traffic in the LAN, because two ports will establish their own connections at a time. You know, 2 ports we establish our connection at a time. So because of this ability that it has, it's able to minimize the traffic congestion. That's an advantage. Also, the switch is able to minimize the traffic congestion, and it's also able to isolate the data traffic in the LAN. So this is another advantage. Although we've talked about isolation before, it's able to isolate the data traffic, like you're just on your own communicating, like 2 people that are chatting, you are enjoying yourself, you're just chatting as if nothing else bothers is happening in the world. It's just about 2 of you, you're just chatting, you're just having fun, right? So the 2 hosts can just be isolated and they're doing their things, right? They're just chatting. So that creates an advantage. That creates an advantage, okay? Or like, so it makes you not have data traffic, because 2 of you can just be having your phone. Now this is a representation, or a diagrammatic representation of a switch when it's used with when it's used in a network. Now here you see the switch at the center. It's connected to one host, which is a computer, could be a computer, this one, and then another one, this one, number 2, another device, which could be a computer, okay, and then the switch can be connected to another switch or a hub specifically, okay. So in order to create another so many set of other device connected to it. So you can see with multiple switches you can have so many devices on the network. Here is a server. the server computer connected to this switch, and then here you have a printer connected to this switch. So you can see how a switch can be used to create a network. Now the change from a hub to a switch is relatively easy, right? Why? Because the port connections are the same. They use the same RJ45. Okay, the connection is same for hub and switches. They use the same RJ45, right? And once the connections are changed and the device is powered on, then the switch begins to make the direct data connections for multiple ports using the layer 2 switching capability. Using the layer 2 switching capability. Okay, so that's what happens. But we're going to show it in a more clearer form, in a more easier form. Now let's take a look at it. Now take a look at the switch. This is a switch, right? Connected to about 16, 8 here on the left, 8 on the. This is a star topology arrangement. This is a star topology arrangement. Now this switch is connected to these devices that are connected. Now we're going to explain this. Okay, now if you take a look at this, you see the computer 1. First of all, if you take a look at this before then, if you take a look at this, you see that this switch has 2 printers that are connected to port 12 and port 16. So you can see this LAN. This switch is used for creating a local area network. Now this local area network contains 14 computers. 14 computers because it has 16 ports. 16 ports. It contains 14 computers and 2 printers. It contains 14 computers and 2 printers connected to this switch. Now this LAN is configured in the star topology, like we've said. Now the computer connected to port 1, let's take a look at this. This computer that is connected to port 1 is printing a file on the laser printer. Look at it. See? The computer connected to port 1 is printing a file, and it sends the file through the switch. The switch sends it to the port 12 where the laser printer is connected. So it's printing a file on the laser printer on port 12. Now let's see the connection. Here is the connection. You can see with these broken lines, red lines. Okay, you see this computer connected to port 1 establishes with a connection with this using the MAC addresses, right? Because this is layer 2 in the OSI model. So using the MAC addresses to make this decision, so both of them learn each other's MAC addresses, and through the switch, this one send here, this one send here, the switch reads them and understand this host on computer 1 on the port 1 is sending a file to printer on port 12 to print a document for them. So that's the first stage, right? The switch will set up a direct connection between the port 1 and port 12. The switch will do the job. Okay, it will set a direct connection between port 1 and port 12. So whatever is happening in this LAN local area network, every other thing that port 2 and any other port is doing, okay, computer on port 2 and computer on port 13, whatever they are doing, doesn't concern these two connections. So that's why data traffic is very minimized. So these two, they're just busy doing their work. Any other thing that's tried to send to this printer will be asked to queue up, to wait, cannot access. This connection till this job is done is over. Okay, we'll be asked to wait until this job is done. So whatever is happening, whether you are chatting and it doesn't concern these two connections that has been established. These two connections that has been established is to print a document from port 1, a computer connected to port 1 on the network. Okay, through using the switch capability, learning their MAC addresses and sending it to port 12 to the printer connected to port 12 of this local area network. Is that okay? That's the first stage. The second stage is that the switch will set up a connection. We've already said that. Now the computer at port 14. Let's take a look at the computer at port 14. The computer at port 14. Okay, the computer connected to port 14 could also be communicating with the computer at port 7. Look at it. A connection has been established here between these two this computer in these various ports. So a computer at port 14 could also be communicating with a computer at port 7. Okay, as you can see, as we've shown in this diagram. Okay, it's connected to a computer at port 7, And then the computer at 6 could be printing a file on the color printer at port 16. Look at it. Computer at 6, the one at 6 could be printing a file from the laser printer at 16, at port 16. The laser printer, the color printer, sorry, the color printer at port 16. So this connection is established now between 6 and 16. Computer connected to port 16 is printing using the switching technology by using their MAC address to make this decision. These decisions are made using the MAC addresses from both devices, both hosts that are connected to this switch. So it will send to the switch will send to the printer, and the document will be printed. The document will be printed. Is that okay? So when this is going on, whatever traffic is happening with other computer connections doesn't concern these two. And these two will do their job. That's why collision, that's why congestion is reduced when we use switch in local area network technology. Is that okay? Now the use of switch enables simultaneous direct data connections for multiple pairs of hosts connected to the network. You can see multiple pair of hosts connected to the network. We've seen that the computer connected to port 1 has established a connection with the laser printer at port 12 to the printer connected to port 12. We've also seen that computer at 14 established a connection with a communication connection between the computer connected to port 7. We've also seen that a computer connected to port 6 established a connection, a printing connection with a color printer connected to port 16. So you can see multiple connections going on with switching technology. This is the super advantage and the super benefit that a switch has, or a switch is able to offer. The super advantage and super benefit that a switch is able to offer, thereby minimizing data traffic and congestion in technology, or like the hub. Okay, the switch technology is able to minimize congestion and traffic and reduces collision. At the rate of data packet colliding with each other is reduced. Okay, is reduced, and therefore it will maximize. If that is reduced, if collision is reduced, this will maximize the use of the bandwidth of the channel. This will maximize the bandwidth. Is that okay? Okay. Now let's move on quickly. Now we say a link with minimal collision is possible since only two computers can establish connection, or will establish connection between themselves. We establish connection between themselves while they are communicating over the channel. So if another computer wants to come in, it will tell, oh wait till it's done with these two computers, they're done with themselves before another computer can establish its connection with that particular port or that particular computer. Now you can recall that in the star topology, each host has a direct connection to the switch. Each host in a star topology, each host has a direct connection to the switch. Each one has a direct connection, or like the bridge, or like when we had a bridge. Okay, would that create a link to a port, not to each one to the switch? So you can see this. So we say because of this reason, when the link is established between the two hosts, their link is isolated from any other data traffic on the network. This link will be isolated from any other data traffic on the network. Okay, because each link has a direct each computer has a direct link, having its own port has a direct link to the switch. Okay, each computer has its own port and has a direct link to the switch. So for that singular reason, this leakage is isolated from any other thing that is going on with the channel. Is that okay? So for that reason, the data traffic will be reduced. However, the exemption to this is when the broadcast or multicast happen. You know, a broadcast, anything broadcasted on the switch will be sent to every port and be received by every device on the network. Is that okay? When broadcast or multicast happen, broadcast messages are sent in the LAN, right? So everyone on the LAN will receive it. In the case of a broadcast message, the message is sent to all the devices connected to the LAN. So a multicast message is sent to a specific group of hosts on the network. just a specific. Multicast is sent to a specific group of hosts on the network. Maybe it could be 4 hosts, 5 hosts, and so on and so forth. But broadcast is every host on the network. Is that okay? Now let's move on quickly. Now let's take a look at the hub and switch comparison. Let's compare them. What you see on your left is a hub with 4 devices connected to a hub, and on your right is also is a switch with 4 devices connected to a switch. Now the objective of this experiment, this is an experiment to find the comparison, the differences between a hub and a switch. The objective of this experiment was to show that the data traffic is isolated with a switch, but not with a hub. So this is the objective. What we want to show with carrying out this experiment is to demonstrate that data traffic is isolated with a switch, but data traffic is not isolated with a hub. So you take a LAN using a hub and a LAN using a switch. That's the first thing you do. You take a LAN while using a hub, or you also take a LAN while using a switch, and then you assemble the system as you can see on the diagram on the diagram, right? So we assemble the system in a similar way. Now each LAN contains 4 computers. As you see, each LAN, look at this. The whole thing is a LAN. This is a LAN. This whole thing is a LAN, and it contains what? 4 computers. It contains what? 4 computers. The other side for the hub, for this hub. Then on the right side you see a Cisco 1900 switch. Now for this for the right side you see a switch. You see a switch with 4 computers as well connected, right? And they are connected in a star topology. Forget the way the diagram is done, but they are connected in what we call the star topology. Now the computers are marked 1 to 4. So we label them 1 to 4. You can see them, the IP addresses, or the IP address. You can see computer 1, computer 2, computer 3, computer 4. On the left side, the same thing: computer 1, computer 2, computer 3, computer 4. So they are marked 1 to 4 for references, so that we can know. Then the IP addresses are listed for each host. You can see the IP address 10.10.10.1, 10.10.10.2, 10.10.10.3, 10.10.10.4. For both sides, the same thing is applicable. Now let's move on quickly. Now when we ping in this experiment, computer 1 pinged computer 3, was pinged against computer 3. That's what we did. Computer 1, in this experiment, we pinged computer 1 against computer 3. Computer 2 was used to capture the LAN data traffic using the Surveyor Demo Protocol Analyzer software. There's a software called the Surveyor Demo Protocol Analyzer software. This software will help us to bring out the result of what we get when we ping computer 1 and computer 3, and we analyze using the capture from LAN 2, computer 2 from the LAN, to show us the data traffic using this demo software. Now, what are expected results? Remember, a hub is a multi-port repeater, right? A hub is a multi-port repeater, and all the data traffic input to the hub is passed on to all the hosts connected to its port. Now, these are the results. You can see the result. Everywhere you get the result. Although you ping computer 1 to 3, but you get the result in all the computers. All the computers that are connected to this hub will get this result. It's like, so everything got the results, okay? However, we're only trying to establish a connection or a transmission or a data packet transfer between computer 1 and computer 3. But at the end of the day, we got in all the hosts. Now let's do with a switch. When the same experiment was repeated for the LAN shown using LAN show, for this time using a switch, okay, using a switch. The first case where we use a hub. When we use a switch to interconnect the computers instead of a hub, what do we get? Now the result we get is that the network consists of 4 computers that you already know, connected in a star topology as in the first case. So we're using the same method so that we see whether we're going to get the same result. So using a switch at the center of the network, the ping command was also sent from computer 1 to computer 3, and then ping 10.10.10.3. That's what we get. So we don't get for everything. We got ping.10.10.3, meaning the LAN has of computer 1, the MAC address has been LAN to computer 3. But when we use a hub, it was like it was broadcasted to every computer connected to the hub. But when we use a switch, it was a connection was only established between computer 1 and computer 3. A connection was only established between computer 1 and computer 3. So you can see that when a connection is established, those two computers that are established using a switch is isolated from the rest of the network. Is that okay? So that's what this experiment has succeeded in demonstrating to us. Now let's move on. Hub switch comparison. Still on hub switch comparison. Now the result of this experiment shows that the use of the switch substantially reduces what we call the data traffic. When you use a switch, it will reduce data traffic in a network. Why? Because the connections, data is transferred between the two hosts that are connected, that have established a connection among themselves. Data is only transferred between two hosts that have established connection among themselves in a switch. Or like the hub, the data will be transferred or broadcasted to all the hosts, all the ports in the network. Is that okay? Okay, that's one. So this will reduce unnecessary data traffic in the local area network. This will help to reduce unnecessary data traffic in the LAN on the network. That's the first point. Now the second point is that the experiment shows that the brokers associated with the ARP, which is the address resolution protocol, which we talked about in 5.2, chapter 5, section 2, address resolution. We said the experiment shows that the brokers associated with the the ARP, which is the address resolution protocol request, is seen by the computers. It's seen by the computers, but not the ARP replies in the LAN using a switch. So you see, the ARP did not reply when we use a switch. It did not reply when we use a switch of other computers that are connected to the switch. But when we use a hub, all of them, they replied. Look at all of them. See the reply for all of them. For the first one, for the second one, for the third one, all of them connected. They all replied. They all gave their own reply. Meanwhile, we did only for this. And the rest of these ones, they gave their own reply. They gave their own reply. Right? So, but when we use a switch, the rest did not give a reply, except the one that computer 1 was pinged to. Computer 3 was pinged to computer 1, or computer 1 was pinged to computer 3, and that's the only connection establishment that we found. Okay, this is because a direct data connection is established between the two hosts. Whenever you use a switch, only the two hosts that are ready to communicate, we establish a direct data connection among themselves. So this will reduce traffic in the network, in the local area network, and this will help to isolate these two hosts that have established their connection to carry out their gist, their communication, whatever communication they want to carry on among themselves. Is that okay? Now let's take a look at the advantage of using switch. One of the advantages of using switch is that it's true for all the data transfer. Okay, it is true for all the data transfer. E.g., the transfer, it can transfer a file, it can carry out file transfer. Switch can help you to transfer any image download that you have. You can transfer file printing, can help you to print, can help you to do download, can help you to transfer files. It can do so many things when you use a switch. So it can carry out so many capabilities, it can do so many jobs for you. Okay, that's one super advantage for doing multiple tasks. Okay, the data traffic is isolated. We've talked about this already. When you use a switch, data traffic is isolated. The reason is that only the two hosts will establish connection. They continue whatever they want to do among themselves. They will continue, and they will be isolated from the rest of the ports on the network, or the rest of the computers that are connected to on the network. So other computers on the LAN will be isolated, right? Okay, thank you. Now let's move on quickly. Let's talk about what we call a managed switch. What is called a managed switch? Okay, the word managed switched. A managed switch is simply a switch, a network switch that allows the network administrator to monitor, help you to monitor, to configure, and to manage certain networks, to manage certain network features like what computers are allowed to access the LAN via the switch, which type of computers are given the permission to access the local area network via the switch. So a managed switch is like a super switch that the network administrator or the IT people personnel, they use to monitor, to configure, and to manage certain network features. like which computer is supposed to go, which is not supposed to go. So that type of switch is called a managed switch. Now, access to the management features for switch is password protected, so that only the network administrator can gain entry. So everyone do not have access to this. Now let's take a look at a good example of a Cisco switch. Let's see, this is a good example of a Cisco switch, Cisco Networks Assistant. Now you see this one has about 24 ports. This switch is called the Catalyst 2950-24. So it has about 24 ports, okay, upon which different device can be connected. Okay, you take a look at the first three, you can see they are colored. Now the correct connections to the ports, it means these three already have established connection. So we say the correct connection to the ports on the switch can be viewed by clicking the stack switch icon at the top of the screen. Okay, now let's move on quickly. Now the image of the switch port connection shows port 1, port 2, port 3 are brighter. You can see port 1, port 2, port 3, they look brighter, they are colored, right? So what this signifies is that there are networking devices that are connected to this port. It means there are networking devices like your computer, whatever, your router, your hubs, or other switches are connected to these ports. That's what this signifies. Now let's take a look at what is being done, an example. How you take this, you can take a look at this, right? Let's move this one this way. So first and foremost, we say if you take a look at this picture, you see that we have fast Ethernet 1, fast Ethernet 2, fast Ethernet. We have this MAC address. We have a MAC address here for a singular computer. We have another MAC address. We have another MAC address. We have another MAC address. All these first 4 MAC addresses, they are connected to what? To interface 1, output interface 1, meaning they are connected to port 1. So how can 4 computers be connected to 1 port? That's the big question that should come to your mind now. You see, 4 computers are connected to, or 4 networking devices are connected to 1 port. How is that possible? It's very possible. How you do this is maybe you bring a hub. You connect a hub to this port, then you connect the 4 computers to that hub. You can connect the 4 computers to the hub. So that hub, the output of the hub goes to the switch. Go to this switch 1. Go to the port 1 of this switch. So that's how we can achieve this. Is that okay? Then you see that another MAC address, this MAC address is connected to the port 2 of this switch. It's connected to port 2 of this switch. And then you see another MAC address again, different MAC address is connected to port 3 of this switch. It's connected to port 3 of this switch. So at the end of the day, you see that we have a sounding victory. Now let's take a look at what we say. 4 MAC addresses are assigned to port 1. We have explained how that can happen, but we're going to still show it diagrammatically. Then 1 MAC address is assigned to port 2, right, as we've demonstrated here. And then another 1 MAC address is assigned to port 3, as we have demonstrated here, right? Now, multiple networking devices can be connected to a port if the devices are first connected to another switch or to another hub. Yes, that's how we achieve this first one, that you see that we have about 4 computers connected to 1 port or on this switch. What it means is that another switch was connected first, or a hub usually was connected first before the output or the interface output was now connected to the switch port 1. Now here is the example we are saying. You see, 1 port from this switch will first of all be connected to a hub that will contain these 4 MAC addresses. Every single MAC address signifies a single device, a single networking device, usually a single computer. Okay, so every single MAC address, every device, every computer has its own unique MAC address. Every computer has its own single unique MAC address. Okay, so here you can see we have 4 unique MAC addresses that are connected to this hub. When they come to this hub, the output interface is now connected to port switch 1, the port 1 of this switch. That's how we got this. That's how we got this 1, 2, the one we say fast Ethernet Ethernet 0/1, fast Ethernet 0/1, fast Ethernet 0/. You can see 4 of them. 4 of these represent these 4 MAC addresses. These 4 computers connected to this hub, and then the output of the hubs take it to the switch. So the output of this hub is what is taken to the switch. That's why you see all of them are connected to port 1 of a switch. So don't be wondering how are 4 computers be taken to only one port. How can 4 computers be taken to one port? The way to do that is to first connect the port of the switch to a hub, and then you take 4 computers to that hub and then bring it to that port. So that's how this is achieved. Now let's move on quickly. Now let's explain the dynamics. What's happening? What's going on? What is happening? Now the dynamics, what is happening is that you can notice that there's what we call the dynamic address tab, and this dynamic address tab is highlighted. This is what you see here. This is what you see here. Don't know. Yeah, this is what you can see. Dynamic address. You see the dynamic address? So you can see this dynamic address is highlighted, right? It indicates that this is a listing of the MAC address that have been assigned dynamically. Okay, it's showing that once you see dynamic address, it's showing that this MAC address has been assigned dynamically, like by default. Okay, by default, it's not manually. Okay, that's what it means. Then we also have what we call the dynamic assignment. What is the meaning of dynamic assignment? Dynamic assignment means that the MAC address was assigned to a port when the host was connected. The moment the host was connected, then the MAC address will be assigned to that particular port. Okay, MAC address, remember, is the media access control address of every computer. Every computer has its own unique MAC address, or every networking device has its own unique MAC address. Now the MAC address will be, once the connection is established, the MAC address will be learned dynamically, automatically, okay, to the port, will be sent to the port, will be learned by the port. And you know the port is connected to the switch, meaning once it's learned by the port, then it's learned by the switch. Is that okay? That's the first step. Then let's move on. We also see there is static address. Can you see? There's what we call the static address. There's what we call the static address. Now the static address, what is it? What does this signify? What does it mean? The static address, a static MAC address, indicates that the MAC address has been manually assigned to an interface, and the port assignment does not expire. It has been manually assigned. It has been done manually. It's not dynamically assigned. That's the meaning of static. So once you see that it is this one that is highlighted, okay, if it is this one that is highlighted and not the dynamic address, it means all the MAC address were assigned manually. Okay, if it is the static address that is highlighted, it means all the address were assigned manually. All the MAC address were assigned manually. Okay, that's what it signifies. Okay, then there's another thing called the secured address. What do you mean by this when this pops up? What is the meaning of secure address? The secure tab or the secure address shows that the switch ports have been secured. The two hosts, okay, the two hosts, you know, every host has its own port. The two hosts has been secured, and which means the two ports has been secured. So that's what this one signifies. Is that okay? And what it means is that the MAC addresses has been assigned to the port, and the ports will automatically disable itself if the device with the different MAC address connects to the secure port. If any device with a different MAC address tries to connect to this, it will disable itself. To disable itself cannot. It's a network has been established between two ports. A network has been established between two ports. Any other device that is not with these two that has established connection will be disabled automatically. Is that okay? Now let's move on. Then we have what we call the fast Ethernet 1/1, fast Ethernet 1/2, 0/2. We have what we call the fast Ethernet 0/1, fast Ethernet 0/2, fast Ethernet 0/3 notation, all indicated here. You can see here these first 4, they are all fast Ethernet 0/1. These 4. Then we have fast Ethernet 0/2. We have fast Ethernet 0/3. So you can see this is displayed here. Okay, display on the interface type. So this shows the interface type or the slot or the interface, right? On the switch, and the fast Ethernet indicates that this interface support 100 megabit per second, okay, and also support 10 megabit per second data rates. That's the meaning of this fast Ethernet. The word fast Ethernet, you already know, we have explained in chapter 3. Okay, so fast Ethernet is showing that this switch is supporting 100 megabit per second. Remember, this is speed, 100 megabit per second and 10 megabit per second. Is that okay? Now let's move on quickly for sake of time. Then there's also something we see, which is called the AG time. You see the AG here. You see the AG. You see the AG here. Okay, there's something called the AG time. It's listed also. In this case, it's showing to be 300 seconds. 300 seconds means 300 divided by 60, which is 5 minutes. Okay, this is showing 5 minutes. 300 seconds means 5 minutes. Now, AG time is the length of time a MAC address remain assigned to a port. AG time is the length of time, how long it takes for a MAC address to be assigned to a port. And this one depends on how long the connection. The moment the two channels no longer communicate, the MAC address will be deleted, will no longer be there. So the AG time is the length of time it takes for the MAC address to be assigned to a port. Now, the assignment of the MAC address will be removed if there is no data activity between the two ports, right? If there is no more data activity between them. Now, if the computer with the assigned MAC address initiate new data after some time again, the computer initiate new data, then the AG time counter is restarted again for the MAC address to remain assigned to the port. So whenever it decides to go back to communicate again with the host, then the AG time is restarted again, and then the computer, the MAC address is relent and to the port again. So now let's go to another thing that you see here, which is called the management window. The management window that you're seeing, this management window, is shows a switch setting for enable AG. You can see enable AG here. Enable AG by default 300. You can see. Okay. Say switch setting saying enable AG. This switch is used to turn off the AG counter so that a MAC address assignment on a port never expires. Okay. So that's what this signifies. Now let's quickly move on. Let's still talk more about switches, a little bit of their benefits and their advantages. The benefit of using a network switch are very numerous, right? In modern computer networks, right? Now, these benefits, they include, like we've said earlier, they include what? They provide us with less network congestion. They provide us with less. I've explained this concept. And then they also provide us with faster data transfer rate, since there is no collision, there is no traffic, and so on and so forth. And there is improved bandwidth, so there is faster data transfer rate. And also provide us with excellent manageability. Excellent manager is able to manage multiple establishment between two hosts that always establish link among themselves. So it has been shown that a network switch can be used to replace the network hub that we used to use. Previously we used to use the network hub. So switch has demonstrated that it can replace hub. And the advantage is data traffic within a LAN is isolated. The big advantage why it can replace a hub is that the data traffic within the LAN is isolated, like in the case of a hub. Now the term for this is isolating the collision domain. So the word we use for this is isolating the collision domains. Okay, what does it mean? Is the breaking the network into segment. So this will help, a bridge helps to break the network into segment, but a switch is able to isolate two connections in order to enhance collision domains, right? So a segment is a portion of the network where the data traffic from one part of the network is isolated from the data traffic from the other part of the network. Now let's still on switches. The direct benefit of isolated collision domain is there will be an increase in the data transfer speed. So we've explained all of this concept. Increase in data transfer speed and increase in the throughput, the capability. Now this is due to the fact that the LAN bandwidth is enhanced. Okay, it's not being shared. It's not being shared, it's enhanced, and then the chances of data collision are usually minimized in this regard. So because of this, the LAN will exhibit faster data transfer rate and then improve latency within the LAN. Okay, the latency will be reduced. Improve in this case means it will be reduced. Okay, the latency will be reduced. The latency is the length of time it takes a data packet to enter a switch and leave a switch. The time period it takes for a data packet to, or a MAC address to enter and leave a switch is called a latency. Okay, so reduced latency means that the data packet will arrive at the destination more quickly and faster. Okay, now let's talk about the CAM. A switch uses what we call the CAM. CAM is a content addressable memory. Switches learn the MAC address of the connected network by extracting the MAC address information usually from the header of the internet data packets. Now the switch will map the extracted MAC address to the port where the data packet came from. It will mark it. The switch will map the extracted MAC address to the port where the data packet came from in the first instance. This information is stored in what we call the CAM, the content addressable memory. CAM is a table of MAC addresses that the switch use. Remember I told you switch also have their table of MAC addresses. Okay, in bridge we call bridge table. In bridge, when we use bridge we call it a bridge table, but in this case it has a memory. Switch has a memory called the CAM, content addressable memory. So it's a table that stores the MAC addresses and the port. It marks the MAC addresses with the corresponding ports used by the switch to identify the connected networking devices. Okay, now let's move on quickly for the sake of time. The extracted MAC address, media access control addresses, are then used by the switch to map the direct communication between the two network devices that connects with the ports. Is that okay? That they want to communicate with. So they use this extracted MAC addresses from the CAM in order to establish the connection and forward whatever they need to forward to each other. Okay, and isolate these two hosts or two ports that have established a connection among themselves. Now the MAC address and port information remain in the CAM as long as these two devices are still connected and they are still communicating. The moment they become inactive, the moment these two link or two ports become inactive, the MAC address will be wiped off. A timestamp establishes the time when the mapping of the MAC address to a switch port is established. Okay, switch limits the amount of time address and port information that are stored in the CAM. Switch will help to limit the amount of time address and the amount of time address and the port information that are stored in a CAM. This is called the AG time. Okay, the ability to limit the time address and the port information in the CAM is called the AG time. Now let's take a look at switches when they use as brokers in broadcast domain. Okay, switch. We already established that switches can minimize the collision domain, right? We already established this due to the fact that they establish direct connection between two networking devices. Why they can minimize collision domain is because why is it that a switch can minimize a broadcast or can minimize a collision domain, whereas a hub may not be able to do this? The reason is that the two hosts or ports, they establish a connection, a switching connection among themselves. Okay, however, beyond this advantage, it is very important to remember that switches do not reduce the broadcast domain. This is for connection whenever the two computers want to communicate with themselves. But when we broadcast on the local area network, The switch do not reduce this. Everything you broadcasted will be received by all the hosts on the network, on the LAN, local area network. Now, in a broadcast domain, any network broadcast sent over the network will be sent by all the networking devices, will be received or be seen by all the networking devices in the network. Now, broadcasts within a LAN will be passed by switches. Once there's a broadcast, the switch will just pass them on. Okay, now let's talk about how the switch work, the modes. How the switch work. The switch is made up of two basic strong modes. The first one is called we say the switch use two modes to forward any packet frame, right? The switch use two modes to forward any packet frame. The first one is called the store and forward mode, and the second one is called the cut through mode. There's another one that uses okay, we'll talk about that one later. These are the two major modes upon which the switch uses, or which the switch uses to operate, to forward data frames or data packet from a frame from one port or from one host to another host on the local area network. Now let's move on quickly for the sake of time. Now let's talk about the first one, which is the store and forward mode. Switch mode, which is the store and forward mode. So we are looking at the store and forward mode of operation of a switch. That's the first one we're looking at now. Okay, now for store and forward, in this mode, the entire frame of data packet is received before the decision is made. First of all, the switch will receive the data packet before the decision of where is forwarding it to it will be made regarding the forwarding the data packet. So before you make the decision of where is forwarding it to, the destination upon which is going to forward this data packet or data frame to, before he makes that decision, he will first of all receive. Okay, that's why it's called store and forward. You will receive it and store it temporarily before you forward it to the destination. Now this is there is what we call the switch latency. Because of these characteristics or this characterization, you receive, you store before you forward inside the switch, before you forward to destination host, or before you forward to the port and the networking device on the port on the destination. Before that takes place, there's always a time lag in the switch. There's a time lag because it receives it first. It receives the data packet first from the host that is sending it, and then it makes a decision. It takes a decision before it sends it out from the switch to the host. So there's a time lag. There's what we call the switch latency. In this, when you are using this mode, store and forward mode, there's what we call the switch latency in this mode, because the destination and the source MAC addresses must be extracted from the packet, and the entire packet must receive it before it is sent to the destination. So you see, there's a time lag. There's a delay. There's a time lag between this before these decisions are made. Now the switch latency is the length of time a data packet takes from the time the length of time a data packet takes from the time it enters the switch until the time it exits the switch. That's what we call the switch latency. That's what we call the switch latency. Now let's move on quickly for the sake of time. Still on the store forward. Now, what's the advantage of using this mode of switch using this mode? One of the advantages of using this store forward mode is that the switch is able to check the data packet for errors. It's always, because it receives this, it checks it, so it's able to check it for error. You check the data packet if there's any error. So if there's error, then he will do what he has to do. If there's no error, then you forward it. So it always check it for error before it send it to the destination. That's a big advantage for store and forward mode. What is the disadvantage? The disadvantage of using a store and forward mode is that it creates a lengthy data packet. Okay, disadvantage is a lengthy data packet will take what? A longer time, a longer latency, switch latency. It will take a longer time before they exit the switch. Okay, and before they are sent to their destination. So there's what we call greater latency. There's what we call greater latency. Okay, and this is a disadvantage, right? Because it takes a longer time, because it receives it there, check for error, and then already extracts the MAC addresses of the host and the destination where the host is sending it to. It will extract the MAC addresses and they check for error, and then before you forward it to the destination. So there's a greater latency. There's a greater latency, meaning the time period it takes for the data packet to enter the switch and the time it takes to leave the switch is a longer time. So this is a disadvantage. This is what? A disadvantage. But the advantage is that it helps you to check for error, check the data packet for error. Is that okay? Now let's go to the second one, which is called the cut through. Remember, we said there are two modes. We said there is the first one, store and forward. The second one is the cut through mode. Now let's take a look at the second one, which is the cut through mode. Now in this mode, the data packet is forwarded to the destination as soon as the destination MAC address has been read. The moment it reads it, it will just forward it. The switch reads the destination. It doesn't have to store it and be checking for error. So the switch receives from a port a data packet coming from a host, and then he reads it, he sees it, and then he forwards it as he's extracting the, like it's just entry. He will read logically it will read the MAC address of the destination, and then he forward it straight away. It doesn't need to be checking for error, waste time, and so on and so forth. This is called a cut through, just cut through. Okay, as the name implies. Now this minimizes the switch latency. Yeah, you already know. Since it just receive and forward quickly, not receive, store it, and the process and the send. So this reduces the latency time. But you know the disadvantage now? There's no check for error. What became the advantage for the store and forward became a disadvantage for cut through, and what became a disadvantage for store and forward became an advantage for cut through. Do you understand this? Okay, good. Let's go on. Now this minimizes the switch latency. However, there's no check for error. There's no error detection that is provided by the switch. The switch will not help you to check for error. Okay, so you can see that what was the advantage for store and forward, which is checking for error, has become a disadvantage for cut through. And what was a disadvantage, switch latency, that was a greater switch latency, that was a disadvantage for store and forward mode of switching, has become an advantage here in this regard. So there are two forms of cut through. Cut through itself has two types. The cut through itself has two types. There are two forms of cut through switching. The first one is called the fast forward. Fast forward. The second one is called fragment free. Now let's take a look at these two types of cut through. The first one is the fast forward cut through. Now this mode offered the minimal switch latency. Fast forward. Okay, fast forward. Like it just goes with speed. Go with speed. Come fast forward quickly. So this one will give you minimal latency, very reduced latency, because the length of time the data packet we spend on the switch will be very small, very little. So it's minimal. So it gives you minimal latency. Now the received data packet is sent to the destination as soon as the destination MAC address is extracted quickly. So you can see this is a fast forward cut through. Now let's take a look at the second one, which is the fragment free cut through. In this mode, the fragment collisions are filtered out by the switch. The switch will help to filter out any fragment collision, because there could be one or two small collision called the fragment collisions. These fragment collisions are filtered out by the switch. Okay, now the fragment collisions are, let's take a look at what that entails or what it implies. The fragment collisions are collisions that occur within the first 64 bytes of a data packet. You remember the data packet that we send over the layer 2 packet is usually 64 bytes of data packet. So you can recall we did this in chapter 1, right? That the minimal Ethernet data packet size is 64 bytes, not bit, 64 bytes. Okay. Now the collision creates data packets smaller than the 64 bytes, and these fragments are discarded. When collision will create data packet that will be smaller than 64 byte. When this happens, this small fragment will be discarded. So in a cut through, is that okay? In a fragment free. So when in a cut through fragment free, then this small fragment that result from collision will be removed. Latency is measured from the time the first bit is received until it is transmitted to the destination. Now there's another type of cut through called the adaptive cut through. Adaptive cut through is the combination of both the fast forward cut through and the fragment free cut through. So when you combine the fast forward and the fragment free cut through, you get what we call the adaptive cut through. So it's a combination of the store and forward mode and the cut through itself. Okay, this adaptive. So we can say there are three modes. The first is the store and forward mode. Sorry, okay, for the first error. We can say there are three types of switching mode for a switch. The first one is the store and forward mode. The second one is the cut through. The third one is the adaptive cut through. But because it bears the name cut through, that's why we don't really itemize it as a different type of switching mode. Okay, but it is what it is. Now the cut through mode is used until an error threshold is received in the data packet or has been exceeded. The cut through mode is used until the error threshold has been exceeded. Now the switch mode changes from the cut through to store and forward after the error threshold has been exceeded. Now let's take a look at multi-layer switches. You know, like when we started, we said most switches are used in layer 2 in the OSI model. Okay, they are used in layer 2 in the OSI model. You know, layer 2 is the MAC address layer, the Ethernet layer in the OSI model is the Ethernet layer, or what we call the MAC address layer. Most switches are used in layer 2 of the OSI model. We treated the OSI model in chapter 1 of this course. Now, but we have also switches that are in layer 3. So we have what we call layer 3 switches. They work at the network level. Remember, layer 3 is the network layer. So layer 3 switches, they work at what we call the network layer of the OSI model. And then we have in this place they use not the MAC address, they use the IP addresses. They use the IP address. The IP address is LAN for making decision. Is LAN and used for making decision. Okay, to the remote data packet, to the destination where the data packet should be delivered. So here in layer 3, when we use layer 3 switches in layer 3, they will not be using their MAC addresses for decision making. They will be using the IP address for making decision and for sending data packets to their destination. So layer 3 switches are similar to router, because remember what router does. Router is the one that uses the IP address, right? So they are similar to router. Okay, they also work at the level at the layer 3 and use the network address for making routing decisions. So layer 3 is like router. Layer 3 switches are working as a router. Let's go to layer 4. Switches can also be used at layer 4. Layer 4 switches operate at the transport layer. Remember, layer 4 is called the transport layer, right? Layer 3 is the network layer, right? Layer 4 is the transport layer. So layer 4, the switches at layer 4, they work at the transport layer of the OSI model. Meaning here we'll be talking about protocols, communication protocols. So layer 4 coordinates the communications between the network. They coordinate the communication between the network. The layer 4 switches identify the application protocols. See, they have to identify the application protocols included in each data packet, and can hand it off to the packets to the appropriate higher level software for onward transmission. So that's it. For layer 4, they use layer 4 use what we call the protocol, data packet protocol, to identify which packet is supposed to be handed over to some higher level software for further transmission. Okay, so that's the end of this section. We've looked at layer 2 switch, we've looked at multi-port bridge, we looked at in our chapter multi-port bridge, a switch being used as a multi-port is called a multi-port bridge because it has so many ports that are connected, and it established connections between two. Once a connection is established between the two ports, they will isolate themselves and start their activities till they become inactive. So we talked about multicast, we talked about managed switch, we talked about hyperterminal, we talked about dynamic assignment, we talked about AG time. So that brings us to the end of this section. Once again, we say thank you for joining our class.